All right, so I've attached a pH review multiple choice page, and it goes from question 1 to question 20. Today we're just going to be looking at the first few because I know the video was a little bit long. So we're just going to do a few questions today, and we are going to wrap up the rest of the questions tomorrow. So just want to make sure that if you need to go back and take the time to review the material, that you are able to do that. And that way you can hopefully get through the questions quicker tomorrow. Or if you just want to sit down and try to get through them all today, that's great. I'll have the answers for you in tomorrow's lesson. All right, so these questions are dealing with pH, the values, and also the hydrogen ion concentrations. So you can see a little bit of the wording that is going to describe how something is having a higher concentration or a lower concentration than something else. All right, so number 1, which change in the hydrogen ion concentration of an aqueous solution represents a decrease of 1 unit on the pH scale? Okay, so first off, if you are decreasing 1 unit on the pH scale, you are getting more acidic. Okay, you are getting more acidic. So think about that. That's going from like 10 to 9, 5 to 4. So you are getting closer to 0. That's more acidic. So if you're describing the change in the hydrogen ion concentration, right away, since you're getting more acidic, the hydrogen ion concentration will be increasing. So I'm going to get rid of the choices that have a decrease in the hydrogen ion concentration. So since I am only moving 1 unit, that means that is only a 10 times increase of hydrogen ions. The way they have it worded here, they call it a 10-fold. Fold also means times. Okay, so your answer is A. There are 10 times more hydrogen ions when you decrease the pH by 1 unit. Okay, so now I have a question here. Which statements describes the characteristics of a 0.001 molar KOH solution? Well, they didn't give me a hydrogen ion concentration. They're just asking me to describe KOH. So I got to figure out what KOH is. Is it an acid or a base? Well, KOH is a base. Remember, take a look at table L. Okay, table L. All right, table K, table L, those are your acid and base tables. So since I have a base, I'm going to get rid of the choices that are calling it acidic. And if it's a base, the pH has to be greater than 7. So my answer is D. My answer is D. All right, when the hydronium ion, okay, this right here, hydronium, I mentioned this on the first page or 2 of notes, that hydronium is the same thing as the hydrogen ion. So this is hydronium, H3O positive. That equals H plus. Okay, it represents that extra hydrogen in the solution that could bond with water. So anytime you see H3O, refer to it as a hydrogen ion when you're dealing with concentration. All right, so if that hydronium or hydrogen concentration is increased by a factor of 10, so if I'm increasing the hydrogen concentration, I should see a decrease in pH. Okay, hydrogen goes up, pH goes down. So I'm going to get rid of anything that says the pH is going to increase. Well, the pH, this is where they're going to try to trick you. If the hydrogen concentration changes by a multiple of 10, that is 1 unit on the pH scale. 1 unit on the pH scale. Okay, and again, flip back to the video and review that if you need to review that. There's probably a few ideas that we covered today and a few ideas from the past week that you might have to go back and review. All right, I have a solution with a pH of 7. It's neutral. When acid is added to this solution, the hydronium ion concentration becomes 100 times greater. Makes sense because hydronium is H+. If I add an acid to it, it's absolutely going to increase that hydrogen ion or hydronium ion concentration. But here's the key. That concentration is 100 times greater. All right, that's going to be 2 jumps. That's 10 times 10 for 100. So that's 2 jumps on the pH scale. All right, so if I started at 7 and I became acidic by 2 units on the pH scale, that would be from 7 to 6 to 5. My new pH value would be a pH value of 5. Excuse me. All right, and last but not least here, when the pH of an aqueous solution is changed from 1 to 2, okay, so we're going from 1 to 2, we are getting less acidic. All right, less acidic. Remember on that scale that we drew, 1 to 2 going up. That means that the concentration of hydronium or hydrogen ions, first it's going to decrease. The more I move away from 0, the more that hydrogen or hydronium concentration decreases. Okay, so the concentration of hydronium decreases, so I'm going to get rid of choice C and choice D. And since I'm only moving 1 unit, that is 1 multiple of 10 for the hydronium concentration. So it's decreasing by a factor or a multiple of 10. So if you're going through these questions with me and you're getting a little bit mixed up between the pH and the hydrogen concentration or hydronium concentration, that is natural. That is kind of like the first mistake people make. That is the first thing we get tripped up on. And we are absolutely going to review that again tomorrow before moving on to the rest of the questions. Please just remember what we talked about in our notes. And I'm just going to show you that again. This is just the filled in value. Okay, that you have 2 different values. You have a pH value, the 8, the 7, the 6, that's your pH value. And then you have the hydrogen ion concentration, which is the actual moles of hydrogen ions floating around in those solutions. All right, so that's where we get mixed up. I know we do. And it's very normal on the first day to get those 2 mixed up. So please don't stress right now. What I will ask you to do is to go back and spend just a few minutes reviewing what we talked about with what those values mean, okay, with the hydrogen concentration relating to the pH. This is going to be very important. This is the basis of this whole idea that we're talking about. And then just seeing that multiple of 10 relationship as the pH changes. Okay, so yes, today was kind of a little bit longer with the notes. Tomorrow will be shorter because we'll be going through the rest of those multiple choice questions. But again, please review. All right, absolutely, please review if you need to. And don't forget about the older material with the Arrhenius and the Bronsted-Lowry theory and the properties of acids and bases. And like I said, you'll be having an assessment on Tuesday after we finish this up with pH questions tomorrow and a little bit of review of everything on Monday. All right, guys, hope everyone's doing well. I'll talk to you soon. Bye-bye.